Hey folks, this is going to be a technical deep dive into the Marmalade search stack. So we have a query loaded here. This is Samba's sneaker alternatives for men. Samba's being the classic Adidas shoe, Adidas Sambas. This will be a great starting query that we can use to illustrate some of the features of the search stack. I'll call out a few front-end pieces as they're relevant, but this will be a little bit more focused on the data science for how we actually take a text query like this and ultimately return a grid of products that we think are relevant for the query. So the first piece is the search experience is mostly quarterbacked by our monolith GraphQL API. And under the covers, it does a variety, it calls a few other external services and does some post-processing and then ultimately provides the information needed for these cards. Also supports some features like pagination. That way we can do some like a nice infinite scroll behavior here. So what will be most interesting or relevant for this discussion is actually going through some of those different pieces of the process kind of as quarterbacked by the monolith GraphQL API. So there's a few things that happened in parallel. The first is the idea of embedding the query. And so we want to take the text here and represent it in some format that's going to allow us to do a lookup on our product index. So we have around 500,000 products that are live and therefore able to be returned in a query. And so we obviously have to do something here to figure out how to match these. So the two main attributes of the search engine are that it is hybrid and it is multimodal. So hybrid in this context means it's a combination of more conventional style queries. Like you can think of classical search algorithms like BM25 popularized in Elasticsearch. These are like inverted indices using techniques like term frequency to look for just not really embed the query per se, but just take these words and look for these words in some kind of product title, product description for these products. And yeah, based on the number of matches there are, how common those words are that matched, we can then come up with a score for each product. That's a very classic search approach. And one thing to say about it is it's actually excellent in the sense of it is famously a frustratingly good baseline. So much of the modern deep learning search approaches need to justify their existence for additional complexity, additional latency, both for training and inference. And so you want to be able to say that we're much better than some standard basic old school search like BM25 or Elasticsearch. And it actually can be very hard to beat. So it's especially out of sample where, yeah, you don't know everything that every document that's going to be searched. It just generalizes pretty well. And so a great baseline, and we benefit from it here. So that's one element of our hybrid search. I may also use the word sparse because indeed we are, you can think of a query as being a sparse vector over the entire vocabulary. So in this case, there would be 1, 2, 3, 4, 5 words that are 1, like are present, and 0, and every other word in the vocabulary is not present with 0. And so we can represent that, very sparsely as like a dictionary or something. So we have a sparse piece. The thing I want to say about that is we actually are not using BM25. We're using a newer model by a French team called Splade. I believe Splade is a play on words, something like a spork, where it's something like a spade and maybe a trowel or some other kind of gardening tool. So it's maybe versatile, jack of all trades is the concept. And the core contribution from Splade is trying to address one of the main limitations of these traditional sparse approaches like BM25, where you're looking for matches in the query with product text or text in your documents, and that is what's called the vocabulary mismatch problem, which is that often there's some kind of there are synonyms, there are related words, there are things that to a human may be very similar, sneaker and a shoe. For couches, it could be a love seat or a sofa or a couch. These are different words, but they're all very similar. And so in the classic BM25 algorithm, unfortunately, we have no help for it because those words are not the same. The algorithm simply can't match from there. And so what Splade does is it adds a BERT encoder, which is kind of one of the OG language models, maybe not a large language model, but a language model nonetheless. And this allows them to basically soften or kind of expand the vocabulary. So imagine with BERT, you can mask a token in a sentence. So imagine we're dealing with this query. We can say Samba's blank alternatives for men, and we could ask the BERT what word comes here, and it's going to give us a probability distribution across several different across the vocabulary. We could take the top options, and probably one of the top ones will be sneaker. Another top one will be shoes. Another top one probably will be shell tops or some other maybe Adidas specific style or term. And we can then index all of those words, not just sneaker. And so now we're able to expand the vocabulary. So we're able to get matches across more products, but we feel comfortable about how we expanded the vocabulary because we used a language model. We did it with some intelligence where we're very likely expanding our vocabulary in a way that's helpful by adding synonyms sort of automatically. So that's great. And we'll give an example, another query where this can be really, really great, which is something like in skincare, where you might want a specific kind of ingredient where you don't just want the vibes of a certain skincare product. You're looking for skincare products that have something specific in them. So being able to do a match where we're able to use that sparse direct lookups, maybe with a little softening around the vocabulary, can be very powerful. And that's why it's one element of our hybrid search. The other half or the other part of the hybrid is semantic, which is around meaning. And this is the more modern approach where we feed some type of embedding model a lot of context about a product, and it represents that in a very dense way. So instead of the vector being the size of the entire vocabulary, something huge, it's much smaller, maybe 768 dimensions, maybe 1024 dimensions, but each element in that vector has some kind of meaning. It's important and necessary for understanding the product. And so for shoes, first you could imagine some elements of this 1024 vector are representing that it's a fashion product or it's a wearable or it's for humans. And then another part would be maybe sneakers. Another part would be casual sneakers, maybe the color brown. All of these sort of elements or any attribute of the product that we find semantically relevant for understanding it, describing it, thinking about it, we would hope is captured in the richness of these some high dimensional embeddings, maybe 1024, 768 dimensions. Once we have that, we can then do a nearest neighbor lookup, which has an analogy to just points in the XY plane, just like 2 points can be similar or intuitively are close together, closer than other points. So too with these higher dimensional vectors, we can readily apply like like a cosine similarity or some other type of similarity function to say which are similar. And so now what we can do is take every shoe, take in fact every product on Marmalade, and turn it into this dense embedding that hopefully has understood all of the semantically interesting attributes of that product, do the same for the query, and then we can compare them and do a lookup to see which are the most similar. So that's the other side. So we have a dense piece. Again, it's dense because every number in that vector is used and is important for storing the information for the product or query. And we can combine those together. And we at Marmalade actually trained our own little alpha trade-off parameter between the two. It's a single trade-off for all queries, but you could imagine an even more sophisticated stack might look at a query, and depending on the type of query, maybe for certain products, you care more about a semantic meaning versus a direct lookup. Totally would be a place for us to extend in the future. And the other part I mentioned, okay, we have hybrid, which is this sparse dense piece. The other part is it's multimodal. And so the sparse side, what we were talking about with Splade, that's taking in product text. We're taking the product title, product description, also taking the merchant title and merchant description, and we're packaging all of that into this sparse vector, showing how often those words are being used, and then softening them with a BERT-style vocabulary expansion. On the dense side, we're actually using the product image as the input for our embedding. So we're using SIGLIP, although you could use, CLIP is the OG here from 2021, where what's nice about both of those models is they have aligned text and image representations in a shared embedding space. And so that allows us to embed this picture and then also embed the text of this query, and then we can do a nearest neighbors lookup on those two vectors to say how close they are, and then do the lookup to find the closest vectors in our index. So this allows us to really nicely benefit from the color, the style, a lot of vibes that are a big part of doing e-commerce queries, and captures one of our big insights, which is that product text and product images are actually complementary sources of information, not supplementary. So product text is not a caption of what's in the image, where those would be supplementary. One describes the other, they're kind of the same thing, just different modes. This actually is often separate. The picture tells you a lot about what it looks like, the style, the vibe of it, and then the product text might be things you can't tell from the picture, like exactly what kinds of materials, the dimensions, something about the process of how it was made. So for us, we actually really benefit from using both sources of information in the query. And so this allows us to handle a wide variety of queries, which is important on a e-com platform that has a huge number of different categories across all of the main areas, from food to decor to clothing, etc. And so the final thing I'll close with is just this really showcases the semantic value of the product, because we're able to see I'm typing Samba sneaker alternatives. None of these products actually list Adidas or Adidas Sambas in the product description, but the embedding model is sophisticated enough to know something about Adidas, know something about Sambas, and it can look at these pictures and it can say, this is kind of in the style of that sort of Adidas shoe. If that's what you're into, these look pretty similar. And so, this gives us a nice ability to combine both modes. Final piece here is a little bonus. We have this for men piece here, especially for certain types of queries. Also, another example might be for species. You might be looking for cat toys, or you might be looking for different age ranges. You might be looking for toys for toddlers in your family. And oftentimes, there can be some really tough edge cases. We used to have a really challenging area of toddler furniture that would show up in regular furniture queries, and so that was a tough one, where you look at the picture and it looks like a great chair, but unfortunately when you look in the details, the chair is tiny and it's meant for 2-year-olds. And so how to solve that, this allows us to do a little bit of query understanding. And so we actually use regexes, and we have just a few categories, gender, age range, species, where we can take a look at the query and make a determination of are the is the user looking for a specific subset of products in this space, and if so, we can actually add a metadata filter to our product. So we've offline run some models to tag each of these products for, is this for humans or for pets? Is this for babies or is this for adults? And using that information at query time, we're able to limit the results to just those. And so that was another quality of life improvement, where we're no longer mixing snacks for pets and snacks for humans, which is often not something people are shopping for at the same time. So a little bonus there of using query understanding to do some harder cut metadata filters to eliminate products and you specify on subsets, and then we can do a ranking between these. Final thing I want to say about our search engine is we do some post-processing to make things even more exciting for the user. You notice here on the first row, we don't really have any repeat brands until we get down here into the end of the second row. And so a couple of the things we try to do is we ask the model, yeah, what do you think the most relevant products are for the query? But then we balance things so that you're getting a diversity of different brands at different price points, varying in a number of different factors, which we broadly term this idea of constructing a menu like at a restaurant or at a wine shop, where you have the ability to see and kind of hone in on a variety of products. You don't just get a wall of products from one brand or a wall of products at a specific price point when you might want to see a variety. And then of course you can filter from there. Thanks.